Hello everyone, how's it going? It's me, Teacher Jose. Today I'm explaining a little bit about the atom. Anyway, I'm going to send you some videos that are much better, although I'm waiting for you to have the class in Zoom. Today we're going to start with some of the basic things we learned before, and we saw it in the last book. It was about the atoms proposed by Thomson. Thomson says that the atom is just like a pie. He actually says that it's like a fig pie, which the figs, figs egos, which the figs are like little pieces, figs and nuts. Figs and nuts will be like little pieces like electrons and um, and protons all together in one huge mess. Thomson saw that maybe matter was a combination of two things altogether: electrons and positive charges. Sorry, electrons are negative charges and protons that are positive charges. Then we go again, Rutherford, by using the number of spin and the behavior of how possibly electrons move around, he proposed the idea of orbits. So according to Rutherford, there are orbits around the nucleus, which the nucleus has positive and negative charges, which are the neutrons. And the idea of neutron and proton starts already, and this idea comes as a nucleus a whole altogether inside. Now, it is proven that there are positive charges running around the nucleus, that most probably they are describing some sort of an orbit that goes around. Later next year, you're going to learn about the spin number, that the spin number is the reason why this theory is proven and takes on. Now, in the next part, we have to understand a little bit of quantum mechanics. So this is not for university type, but it's quantum mechanics 101. Now, guys, we already saw the principle of do you remember the Schrodinger's cat? That the cat technically is living in two states. Today we're going to see over that overlapping of two states by finding the first thing, that is quantum mechanics. In quantum mechanics, the atom now it's demonstrated as a different thing. The quantum mechanics actually has a more appropriate use, or a more appropriate approach of how an atom actually might be. We have that in quantum mechanics we have a nucleus, and the nucleus it has protons, which are positive charges, and neutrons as well. This sort of electronic cloud is the reason why I put it like dots in around the nucleus, is how we can actually see an atom anymore. We cannot see it anymore like this or anymore like this, because these are wrong methods. By quantum mechanics, we actually can tell that the electronic clouds is actually the right way to see an atom. Why? Because of this thing that is called the Heisenberg principle. The Heisenberg principle, you just see this formula, but I'm going to explain it, like narrow it down very quickly. It means that, for example, here we have a distance and we have a momentum. The momentum is the velocity of what something is traveling with, and the distance is the I would say the place or the position where it is. Now, what does it mean by saying this? That we don't have an exact value if we found the atom, especially one electron. What do I mean by saying this? It means that if I am in this huge CERN, the CERN is a collider. It's one, if you remember in game, we saw that they were trying to do one huge collider of electrons. Is a place where, I'm going to send you anyway, what is the CERN? Is in Switzerland. The CERN is a place where you have is a huge tunnel where there is I would say something like a path where electrons travel, and these electrons in the CERN have collisions. This is a place where we study physics at the maximum level. They have proof that if we know where the electron is, we don't know if it is an electron. So what do I mean by saying this? It means that if, for example, I am using, let's imagine this little thing, a detector here, okay? Yeah, I'm gonna have here. And imagine this is the path where my electron accelerator is traveling. And here, I detected something. And I say it's an electron. Okay, I detect an electron, however, I don't know where it is. This is why I will say that if I know what it is, because the momentum will give me its mass and its velocity. If I know what it is, if I know it's an electron, because it has the characteristics of an electron, I will not know where it is. So look at this, I don't know where it is. I know it's an electron and I know it's here, but I don't know where it is. Then what happens if I know where it is and I find it? And let's say I found it here. And I know that my particle that I reported, it's here. I found it, it's here, it's there. The question is really an electron? I don't know. It might be a neutrino. It might be a muon. It might be a tau particle. I don't know. So this is what the Heisenberg principle is. You don't need to know much more if you want to study chemistry or physics in college, or maybe biology. We will see this again. But this is what it means. It means that, for example, if you need to have a perfect or more accurate of what an atom model is, we need to understand that we don't know exactly where the particles are. We know they are there. We know they are there. We know that we have this sort of particles, and we have found quarks and all of those. But we don't know where they are. We don't know where, honestly, and if we know where they are, we don't know what they are. That's the sad part. This is the principle of Heisenberg. So Heisenberg, in his interpretation of the Copenhagen structure, he says that it's impossible to know so far with the technology. Maybe when you're like old enough, or maybe there comes a huge mind who starts understanding more about technology, possibly Elon Musk in his Tesla laboratory. Just kidding. Tesla is not about the cars. Tesla is about, well, technically he produces the cars, but Tesla is one of the biggest scientists that have ever existed, and Elon Musk took over that name. Anyway, if you see it, Heisenberg demonstrated this part, and we only know statistically. What I mean by saying statistically, it means that, for example, if I go over a shape in the statistics, I know a big probability where I can find my electron or my particle, but not anymore, guys. This is like my highest probability, low probability, low probability. But even so, if I know where it is, I don't know what it is. It's just a high probabilistic state. Well, that's all for today, guys. If you have further questions, let me know. I'm going to show you some of the atoms models in another link that is going to be associated to your Irukai account. Take care. Bye.